Okay, in this next section, we're talking about angle bisectors and the angle bisector theorem, which states that if we have an angle bisector like this, then from any point that is on the angle bisector, which in this case the angle bisector is FJ, if we draw lines from J to ray FG and ray FH so that it's the shortest distance, again, has to be perpendicular. If these two distances are the same, then it's definitely an angle bisector, and this angle is 42 degrees. So in this case, the measure of angle GFJ ends up being 42 degrees. So yeah, basically, again, if we have a point that's on the angle bisector, then the distance from this point to either side of the big angle, if we draw it and the distances are the same, then these angles have to be the same. Again, JG perpendicular to ray FG, JH is perpendicular to FH, and we know these two lengths are equal, so we know this bisects it, and it's the converse of the angle bisector theorem, so that we know that these two angles are equal. Here's another one where we know these two angles are going to be equal, and we want to know, will the goalie have to move farther to block a shot towards the right goalpost or the left goalpost? So in this case, if we look at it carefully, the distance should be the same, because it's going to cut it directly in half. Sorry, let me go back real quick. If these two angles are the same, then the distance from here to here should be the same as the distance from here to here. So again, congruent angles tell you the goalie is on the bisector. So basically, let me go back one more time. So since the goalie is right there, we can draw a line going this way so that it's perpendicular, and we can draw a line going this way so that it's perpendicular, and these two distances should be the same, therefore they would have to dive the same amount in either direction. Okay, so the same distance either way to block the shot. And here's another one where we want to know what value of x does P lie on the bisector of A. So if we were to draw a bisector that did go through like so, then we would know that this distance, PB, would be equal to PC, and this would be an angle bisector, so it would cut it in half. So basically all you do here is say that x plus 3 would have to be equal to 2x minus 1, and then you'd solve it. So subtract x from both sides. 3 is equal to x minus 1. Adding 1 to both sides, x is equal to 4. So x would have to be 4 in order for P to be on this ray AP. Again, converse of the angle bisector theorem tells us that P lies on the bisector of angle A if it's equidistant from the sides. So therefore we'd have to have BP and CP equal. So we do that, we plug in our values, and we solve for x. Okay? And here's another one. Again, this is an angle bisector. That tells me that these two lengths have to be equal, so PB and PC would have to be equal. X would have to equal 15 here. Here's another one. We know that PB and PC are equal, therefore these two angles are equal, and we would be able to write that 4x minus 6 is equal to 3x plus 5. Solving for x, we subtract 3x from both sides. We get x minus 6 equals 5, and adding 6 to both sides, x is equal to 11. And here's one more. Again, these two angles are equal, so these two lengths, PB and PC, show that point P is equidistant from either side of the angle there. So we would be able to say that 6x minus 5 is equal to 5x if we subtract 6x from both sides. We get negative 5 is equal to negative x, and dividing both sides by negative 1, x is equal to 5. And here's one more. We want to know if there's enough information to show that QS, ray QS, bisects this big angle PQR. If you look, the distance from P to S is the same as the distance from S to R, but the only problem is that this is not perpendicular and that's not perpendicular. It needs to be the perpendicular distance in order for it to be the shortest distance. And there has to be some equality in terms of this, because we could draw any line that would be equidistant. We need them to be perpendicular on both sides. So again, we would have to state that SR and QR would have to be perpendicular, and also SP and QP would have to be perpendicular. And we're done here. Thanks.